All right, so we saw in the last section that we can do pretty simple calculations with the column. So let's go ahead and bring in our Ames data. And what we saw was an example like this where we took Ames sale price and we could just divide this by 1,000, right? And this would give us sale price in thousands. And if we wanted to save this to a variable, we could just say sales price, okay, meaning sale price in thousands of dollars. And we could go ahead and assign that and save that. And we now have that column in our data frame. Right, so we call this vector scalar math because what we're doing is we're taking a vector. Here, the vector is our series, our sale price. And we're dividing it by a single number, a scalar. This is 1,000. But nice thing is we can actually do what we call vector-vector mathematical operations. So I could say, well, let's take the sale price and let's go ahead and divide it by the square footage. Right? And the square footage is ground living area. And so now what we see is we actually get the price per square foot, right? And this is actually a pretty standard metric used within the real estate industry. And so what I could do is I could save this now as a new column because you can see the output is a series. So we can just assign the new column the values of this series. We could say price per square foot. If I look at Ames head, I could scroll over and I can see that I now have that price per square foot in there, right? Now we can do all different types of combinations of this vector scalar math or even vector. So for example, I could even adjust this to be the Ames price. Well, actually, here, let's use this. We had the sales price K, right? So let's say that was our column of interest. But what we wanted to do was, let's say, to get the price per square foot, we would need to take this, multiply that by 1,000. So this is doing a vector scalar mathematical operation to get this back to the original sale price value, and then dividing it by another vector, right? And so I could do that, and we should end up with the same answer, right? So you can see we can do any kind of combinations of these operations with one another. All right, so let's go ahead. Let's use this information, and we're going to answer the knowledge check. Create a new column, price per square foot, that is sale price divided by the sum of the square footage area, total basement square footage, wood deck square footage, and open porch square footage. So don't know if this is a real valid metric to use, but it just kind of illustrates the point. And what we can do here is we can take Ames, and we're going to use sale price. Right, that gets us our series of sale price. And I want to basically divide that by Ames ground live area plus Ames. This is total basement square footage plus Ames wood deck SF plus Ames open porch SF. All right, so you can see what we do here is we're just going to add all these up. We include those in parentheses just to specify I want to do that first. And then we'll take the total value there and we're going to go ahead and that's going to be our divisor for sales price. right? We see we get our result here. Now, when you do something like this and it gets pretty long, it is kind of nice to go ahead and we could break this up. We could say total square foot. And now I'm going to just save that output. And I could then say sales price divided by total square foot. And I want to save this as a new column, which we're calling Ames price per total square feet. And if we look at our data frame, we now scroll all the way to the side here and we see we have price per total square foot. And that is the calculation of the sale price divided by these, 4 other variables summed out.